So in the previous video we agreed that there are many different levels of organization we can actually have the DNA compacted in. And we agreed in the end of the video that there is something called epigenetics. And epigenetics is where you have different transcription of DNA into RNA into protein in different places of the DNA sequence, but we don't actually change directly the DNA sequence. We change its surrounding. And we also mentioned that there are two chromatin condensation forms. One is the one you can transcript, which is called euchromatin, which is the less dense form of DNA. And two, which is heterochromatin, which is the more dense form of compaction of the nucleosome. But what is the difference between the two? We mentioned that DNA, due to the phosphate groups, is very negatively charged. We also mentioned that histones are positively charged proteins, and they are positively charged because we have R groups, amino acid with positively charged R groups. Now, when we combine plus and minus, they will want to naturally attract each other. Therefore, you have the compaction of the DNA around the histones. However, if we add specific functional groups to the histones or to the DNA itself, but now we are talking about the histones, we will get the formation of either euchromatin or heterochromatin. We are going to change the polarity of the charge of the different either proteins or the DNA. And when we do it, we are going to either form the euchromatin and a heterochromatin, because we are going to act and we are going to change the balance between the charges. So let me give you an example. If we come and put a functional group called acetyl, which is the following group, which is negatively charged, and we are going to put the following acetyl group on one of the histones amino acids, and we are going to put more negative charge on one of the following histones that are positively charged. We are going to cause a repulsion between the histone and the DNA. Therefore, we are going to get a more relaxed state of the condensation of the DNA. Therefore, it's going to be easier to transcribe this section of the DNA. We call this process of acetylation, activation. We call it acetylation, and I call it activation of the DNA area. So where you acetylate, where you put acetyl groups on the histones or the DNA itself, you are causing a more relaxed state and more free form of the DNA. On the other hand, if you want to create a more dense, condensed chromatin, and you want to disallow, you don't want to allow, you want to mute this section of the DNA, you're going to put methyl group. And methyl group are just carbon with the hydrogens. This is methyl group. Putting methyl groups either on the DNA or on the histones are usually going to stop transcription. And putting acetyl groups on either the histones or the DNA is going to activate this area of the DNA and cause transcription. Now, if you have acetylation, you obviously have deacetylation. And when you deacetylate something, you mute it again. When you acetylate it, you activate it. You can remember it from A for acetyl for activation, and M for mute and deactivation. So let's sum this video up. Histones are positively charged. DNA is negatively charged. Where we add a negative charge to either the DNA or the histones, we are going to cause a more relaxed state of the nucleosomes, and therefore we are going to be able to transcribe this area of the DNA. It's going to be activated. On the other hand, we have heterochromatin, which is the more dense form. And when we use methylation, which is the setting of methyl group on either the DNA or the histones, we are going to cause the muting of the DNA of this area. Now, because this process doesn't directly change the sequence of DNA and only cause the activation or deactivation of the DNA segments, therefore you have different protein, we call this process epigenetics. Epigenetics is where you cause the change of things around the DNA that cause it eventually a different set of proteins, but we don't have any change in the sequence of DNA. And this was just a brief introduction where it comes to epigenetics and what we do, which chemical modifications we do to the histones or the DNA itself in order to cause either activation or muting of the transcription of the different segments of the DNA. I hope this video made sense, and I will see you next time.